Alright, let's get into it. Ever wondered how your car, this massive machine of steel and fury, actually moves? It's not just magic, it's a legendary battle of power. It starts deep within the engine. Think of the engine as the heart of a titan, a powerhouse forged in fire and precision. When you turn that key or press that start button, you're not just starting a car, you're awakening a beast. This beast doesn't just roar, it creates a colossal twisting force. We call this force torque. Imagine trying to open a super tight jar lid. That twisting effort you're using, that's torque, my friend. And the engine makes a ton of it. It's the raw, untamed power that wants to break free. But torque is only half of the story. The engine also spins incredibly fast, thousands of times every single minute. We measure this speed in revolutions per minute, or RPM. So you have this immense twisting force in one hand, torque, happening at a crazy high speed, RPM. Picture this, a mighty warrior spinning a giant war hammer. The force of the hammer is the torque, and how fast he spins it is the RPM. The engine's job is to create this powerful combination and hand it off. The entire journey of this power, from the engine's fiery gut all the way to the rubber that meets the road, is what we call the drivetrain. Now that our hero, torque, has left the engine, it immediately meets its first gatekeeper, the clutch. In a manual transmission car, the clutch is like a powerful spring-loaded plate you control with your foot. Think of it as a drawbridge. When you press the clutch pedal down, the drawbridge is up and the engine is disconnected. The engine can spin freely, but that power goes nowhere. This is how you can sit at a red light with the engine running. When you let the pedal up, the drawbridge lowers and the plates clamp together. Bam! Power is connected. The beast is unleashed, and torque continues its journey. In an automatic car, a torque converter does a similar job, like two fans facing each other moving fluid. Once past the clutch, our power slam dunks into the gearbox, the transmission. This is where the real magic happens. The gearbox is a master strategist and a wizard of gears. Its mission is to trade speed for power, or power for speed. First gear is huge and mighty. It slows the spin way down and multiplies torque like crazy. This is your Hulk smash gear, perfect for getting the car moving from a standstill. Engine 200 Nm, gear ratio 3.1. Gearbox multiplies torque to 600 Nm. But triple torque costs speed. Our hero, the newly magnified 600 Newton-meters of torque, has conquered the gearbox, now ready for the next leg of its quest. It bursts out of the transmission onto the driveshaft. The driveshaft is the unsung hero, the long-distance messenger. In a rear-wheel drive car, a long, hollow tube, steel or aluminum, runs down the center of the car, under your feet. Its job is simple but critical. Carry the spinning power from the gearbox to the differential at the back. But it's not a straight path. The suspension moves up and down, soaking up bumps. If the drive shaft were rigid, it would snap on a pothole. Solution: universal joints, U-joints. Like the drivetrain's elbows and knees, a U-joint bends in any direction, transmitting power when angles misalign. In front-wheel drive and all-wheel drive cars, meet the constant velocity joint, CV joint. Ball bearings run in grooved tracks, feeding smooth power through wide angles at constant speed. The drive shaft spins, carrying 600 Newton-meters down its length. High speed, high torque, perfectly balanced to avoid vibration. Think of it as a lance, aimed and stabilized from the night, the gearbox, to the front line, the rear axle. Simple part, profound role, connecting the power-making front to the power-delivering back. Without it, the engine's roar would be an empty threat. The drive shaft ensures the power gets where it needs to go. After its long journey down the drive shaft, our 600 Newton-meters of torque arrives at its most clever and cunning opponent yet, the differential. The diff is a compact box of gears sitting in the middle of the axle between the drive wheels. Its first job is simple. Turn the power 90 degrees, pinion to ring gear, then out to the wheels. But the differential has a bigger secret. It divides the power. It lets the two wheels rotate at different speeds. Think about turning a corner. The outside wheel travels farther. If both wheels were locked together, the inside wheel would skip and chirp. The outside would drag. Inside are small spider gears. They split torque evenly between the wheels. 600 in becomes about 300 to the left and 300 to the right. But torque is equal while speed is not. The spider gears let one wheel slow and the other speed up, as long as their average matches the input. That's why cars turn smoothly. The weakness: if one wheel is on ice or mud, the diff can't send extra torque to the grippy wheel. One wheel can spin uselessly, while the other does nothing. Engineers solve this with limited slip differentials and locking diffs. For most daily driving, a standard open differential is the perfect hero. Strategy mastered, power judged, path clear. The journey is almost complete. The power, now turned, split, and ready, flows into the last warriors, the axle shafts. These are strong steel rods that connect the differential's gears directly to the wheels. Each wheel gets its own axle shaft, carrying its share, a mighty 300 Newton meters. Solid axle is simple and strong. Independent lets each wheel move for a smoother ride. The axle's job is to spin the wheel hub with all the force it's been given, from the engine's core, multiplied by the gearbox, carried by the driveshaft, and split by the differential. Now, it has reached its destination. The axle spins the wheel, and the wheel turns rotational force into forward motion. This is where the rubber meets the road, literally. For every action, there is an equal and opposite reaction. As the tire pushes the road backward, the road pushes the car forward. That's the moment of victory. All that complex engineering, all those gears and shafts, all that fire and fury, just to create a powerful push against the earth. From 200 Newton meters at the engine to 300 at each wheel, the power has been transformed and guided on an epic quest. The smallest gear and the beefiest U-joint must work in perfect harmony. It's a team of mechanical heroes achieving motion. Next time you press the gas and feel that surge, remember the army beneath you and drive it like you built it.